Hello! Time for another episode of Vibes of the Universe. Just like before, I will begin with some geomagnetic instabilities. Around midnight, 27-28 of October, European magnetometers recorded a long-duration magnetic impulse, which reached more than 400 nanoteslas at lower latitudes. Second one was much shorter, and it took place around hour before I started to record this movie. Both impacts affected greatly the readings on Kirona magnetometer, and K index was raised to 6 during the first disturbance. That's a sign of rather strong geomagnetic storm. But much more disturbing is the ryometer chart, where we can see a strong penetration of plasma around 10 hours after the stronger geomagnetic pulse. And the first pulse was strong enough to cause quite strong auroras, which reached 110 gigawatts of power. Such values can be seen only during strong geomagnetic storms. And when we'll look at the readings from magnetometers in Canada, where the range was elevated to 300 nanoteslas, we won't have any doubts that whatever caused this disturbance, it affected bigger part of the planet. Poor Noah obviously has no idea what is going on, as the KP index was raised only to 4, while all signs tell that it should be at least 5. But I can understand those people, as their entire space weather model doesn't work at all any longer. There is again nothing on ACE readings what would explain all those instabilities. After a couple days, during which the geomagnetic field was relatively calm, another sudden geomagnetic pulse took place in the evening of last day of October. However, it wasn't such strong as the previous one. It was recorded as well by Canadian magnetometer stations at higher latitudes. The only space weather activity during this time was this sudden shift of IMF-BZ component from negative to positive values, which was recorded by ACE satellite 2 hours earlier. Of course, it doesn't make sense, as the geomagnetic field is sensitive for negative, south BZ orientation. During the time of quiet geomagnetic conditions, two events took place. First, Earth passed through a sector boundary, and now we're placed in a part of heliosphere with positive magnetic orientation. Then we were hit by a very dense wave of plasma. Density reached 140 particles per cubic centimeter. Of course, I couldn't miss the opportunity to look at the impact on SWMF magnetosphere monitor. Notice the plasma discharge which took place soon before the arrival of density spikes. This is a good moment to look at the magnetic polarity of Sun. There is a clear positive flux tube which is currently placed on the departing limb. The rest of Earth-facing disk has negative polarity. The flux tube has its origin in a positive coronal hole. However, the Stanford MHD simulation doesn't show that there is a second hole right above it, and it has opposite magnetic polarity. Notice that there is as well a second negative coronal hole on the southern heliographic pole. This shows how badly screwed is the magnetic field of our star. Now it's the time to look at Kirona ryometer graphs from the second half of October. As you can see, during the last couple days, the disturbances started to grow in strength. And because the magnetometer readings don't have too much with the ryometer disturbances, I will have to talk about another way of measuring the properties of ionosphere. I mean using the radio waves propagation. Here, the colors represent frequencies which are being reflected by the ionospheric plasma and returned to Earth. The thicker is the F2 layer, the higher frequencies will be reflected. Over the equatorial region, where density of electrons is highest, frequencies below 14 MHz won't penetrate the ionosphere. Above the polar caps, where the amount of energetic particles is much smaller, waves above 6 MHz will pass through the ionosphere and move into space, what will weaken the signal strength. However, on coronariometer, the frequencies are higher, 30 and 38 MHz. Those waves should be weakening only when the density of electrons is well above average, like during geomagnetic storms. And this is the third way to show the reflected frequencies: ionograms. Here the vertical scale shows the height in kilometers, while the horizontal one represents the frequencies. Normally, waves at frequencies bigger than 7 MHz supposed to be completely absorbed, while smaller ones should be reflected at 250-300 km above the surface. Now look at the readings recorded by Lixele ionogram on October 31st. Notice the changes of height and range of frequencies. During the daytime, the range of reflected waves grew to 12 MHz at very low height, and it happened at the time when coronariometer was freaking out. This is the sign of very strong plasma pressure. It seems that there were two separate impacts in last 48 hours. First one was preceded by the frontal density wave, what tells me that we're probably dealing with two coronal Hall streams. However, the density remains slightly elevated, what doesn't fit to this image. Second impact of faster particles was connected with the increase of low energy protons, what can be explained by the positive magnetic polarity of departing Hall. But it can be as well a sign of a CME. I don't know which option is correct. This is interesting. It looks that around 16 UTC on 1st of September the amount of ions at higher energy bands and electrons started to grow. It's a sign of proton event, a direct Earth-Sun magnetic connection. Particles started to enter the inner magnetosphere already, in the difference to the first proton wave recorded by ACE, which was not noticed by GOES satellites. According to LMSAL, It was caused by this extremely spectacular filament ejection. This is as well odd, as the incoming limb is causing proton events or flux transfer events much less often as the departing one, because of the Parker's spiral. It would be nice if those two events were somehow connected with the two strongest quakes of last 24 hours, but it looks that there is no visible correlation. First one was a 6 magnitude quake on Easter Island, which took place at 11 UTC. 8 hours later, a 7.1 magnitude earthquake hit the Fiji region. Although the KP index was low and there wasn't almost any geomagnetic activity during this time, the magnetosphere behavior was far from being normal. Soon before the first quake, the backside pressure visibly started to grow. A stationary sector boundary emerged on the far side of magnetotail. There is a hole in the data, and the images from 11 UTC are gone from the SWMF plus RCM monitors. However, the old monitors show a plasma outflow taking place right at the time of quake. And now the best part. Look what's happened at the same time on plasma temperature monitor right over the epicenter. The main equatorial connection divided into two flux tubes, where one remained connected to the area of earthquake. This reconnection affected the ionospheric electrons at lowest levels. But let's go back to plasma temperature. Notice that there is a visible connection between the equatorial flux tube and northern pole. At the time of Easter Island quake, the connection was cut out. But look what happened some 8 hours later, close to Fiji region. Temperature of plasma visibly dropped right at the epicenter of the second quake. It was caused by another magnetic reconnection, which can be seen on the SWMF plus RCM monitors. No, magnetosphere shouldn't look like this. Now look, as right at the time of the second quake, a weird impulse of energy appears out of nowhere in the area between the bow shock and the magnetopause. This sudden impulse changes greatly the magnetic connection between Earth and low energy field. Before, the western part of magnetopause was transferring the particles. When it was disconnected, the energy was unleashed and the connection was established over opposite side of the planet. Couple hours later, there was a second discharge and the connectivity returned to its previous state. It's nice to have all my toys back. And this is the best moment to move to more complicated part. As you can see, the radiation belts were again discharged from the electrons. Just as the current rings, but they lose particles much more often, and in their case the charge already started to move back. Notice that there are again two flux tubes connected to the protons at lowest energy bands. Sorry, those were electrons, not protons. My mistake. This allows me to connect nicely the current ring monitors with the behavior of plasma in the ionosphere. Process which possibly triggered the Easter Island quake is taking place almost every day and it can be seen on multiple monitors. They work with each other perfectly, but those who watch my movies for a longer time should know that I've managed to couple those two models quite long ago. You can see nicely how the connection point moves from the one part of the planet to another. And this is another part of the same process. Current rings are being discharged on daily basis, and I'm sure that it is caused by the connection with low energy field. But I will talk about it in next episode. Cause I still have to show you another nice example of magnetic field line affecting the atmosphere above Hawaii. This time, the low energy field tentacle stick to the equator. Second one appeared over the Atlantic. New type of clouds. Stratus tentaculus. Okay, that's it for today. Class dismissed. Be safe. Peace.